In a previous exercise, we calculated that in this setting, the equivalent martingale measure is given at values omega 1, 2, 3, and 4 by 4 over 9, 2 over 9, 2 over 9, and 1 over 9, where Q of omega I equals Qi. It follows, just using the definition of conditional probability, that omega 1 given omega 1, omega 2, which I shall now neglect to put those curly brackets in the notation, but of course that's what's going on. I should officially really be there as well, is 2 over 3. Omega 2, given the same event, is 1 over 3. Probability of omega 3, given the event omega 3, omega 4, is 2/3. And the probability of omega 4, given the same event, is equal to 1/3. In our setting, we have, by assumption of the fact that Bt is equal to 1, that H is equal to C. And therefore, that expectation of ZQ at time 2, given F1 under Q, this is all expectation under the equivalent martingale measure, Z2Q is equal, H2 is equal C2 by definition of the Snell envelope, so this is equal 10 times 2/3, add 30 times 1/3 on the event omega 1, omega 2, just using the conditional expectations or conditional probabilities that we calculated above, plus 20 2/3 plus 60 1/3 on the event omega 3, omega 4, using the values that C takes and these conditional probabilities that we calculated above. Just doing the arithmetic, that's 50 over 3 on the first event and 100 over 3 on the second event. And that should be an indicator. It looks more like an H, but it should be an indicator. Thus, working backwards to calculate the Snell envelope, at time 1, which is the max of C2 and the expectation, it's equal to 50 over 3 on the event omega 1, omega 2, but on omega 3, omega 4, it's equal to 60, because 60 is larger than 100 over 3. Going back another step, actually, what we also want to do now, in order to go back to another step to calculate Z0, we need first to calculate the conditional expectation of Z1Q against F0, but of course that's the trivial sigma algebra, so this is just the expectation of Z1Q, which is equal to 50 over 3 multiplied by the probability of omega 1, omega 2. This we know from our calculation in the previous exercise. We know the values of Q at all the omegas, so we can just plug them in. and the value we get is 280 over 9. Now we can calculate the value of the Snell envelope at time 0, which is the maximum of C at time 1, and this expectation, which we just calculated, since C at time 1 is either 10 or 60, 280 over 9 is larger than those. 280 over 9 is the initial value of the Snell envelope. Now we want to calculate tau min and tau max. From the calculations above and the definition of tau min, we see that on the event omega 1, omega 2, tau min occurs at time 2, but on the event omega 3, omega 4, tau min occurs at time 1. We know already that tau max has to be greater or equal to tau min. That follows from some previous exercises. So at least on the event omega 1, omega 2, tau max also has to equal 2. That's the terminal time, and tau max must be larger or equal to tau min. On omega 3, omega 4, we see that from our calculations, the expected value of ZQ2 given F1 is not equal to ZQ1. We calculated these both. ZQ1 is equal to 60, and the conditional expectation is equal to 100 over 3. They are not equal, right? And therefore, by definition of tau max cannot be equal to 2, and since it's larger or equal to tau min, it must be at least 1, so in this case it's equal 1. So in either case, tau min is equal to tau max.